Welcome to the third day of Summer General Physics. In this fifth video, we'll be looking at parabolic motion. So parabolic motion occurs whenever you have a thrown object that moves in both the x and y directions. So far when we were looking at free fall, we were only considering a very special case where a thrown object moved straight up and then straight back down again. But more generally, a thrown object can move in both x and y, and the path looks like a parabola. So one kind of device that's very good at making parabolic motion is a trebuchet. So you can see here a physics club that has built a trebuchet, which is a piece of ancient artillery used for throwing pumpkins in this case, and they have aptly named theirs the pumpkin pie, which is of course what happens when the pumpkin reaches the ground. So the important thing to realize about parabolic motion is that you can split this motion, even though it looks complicated, into x and y directions. And if you do this, you can see that the motion becomes very simple. In the x direction, there is no force on the object. Gravity is the only thing that is pulling on the object, and it only pulls in the y direction. So since gravity acts in the vertical direction only, that means you can treat the motion in the x direction as constant velocity motion and the motion in the y direction as free fall. So this makes it very easy to break the motion into x and y components and analyze each component separately. Now when we have a parabolic motion problem, one of the things that we'll have to do typically is break the initial velocity into x and y components, so that we can then write down equations that apply to the x and the y directions. So often our initial velocity will have some component in both directions. And if that is the case, then we will need to break this motion into x and y components by using trigonometry. So if the angle is the launch angle, then as you can see here, we can use the sine of that launch angle to figure out what the y component of the velocity is, and the cosine to figure out what the x component of the initial velocity would be. So as we mentioned before, there is no acceleration in the x direction. Once a parabolic motion object is launched, once it leaves the launcher or leaves the thrower's hand, there is no force in the x direction. There is no acceleration in the x direction. So the velocity in the x direction is constant. The initial velocity in the x direction is the same as the velocity in the x direction at later times. So we can use a constant velocity equation. In the y direction, we do have acceleration because gravity is pulling on the object in the minus y direction, and so we can use any of the free fall equations in the y direction. Now one thing you'll notice about the two equations I have written here is that they are linked by time. So often it will be the case when presented with a problem that you'll have enough information to solve one of these two equations for time, and then you can plug that time into the other one to find the quantity that you're interested in solving for. So that concludes this video. Before you watch video 6, where we take a look at some parabolic motion examples, be sure to watch the video on the kayak. The kayaking video will give you some context for the first problem we do in the next video.